Okay, in this problem, we have a person taking a prescribed dose of Valium, 4 milligrams, and the amount in that person's bloodstream at any time can be modeled with this function where t is in hours. So the first question is how much Valium remains in the person's bloodstream 6 hours after taking a 4 milligram dose? And we're going to round to the nearest tenth of a milligram. Okay, so 6 hours later, we're just going to find A of 6. That will give us the amount in the bloodstream after 6 hours. So we're going to find 4 times E to the negative 0.0133 times 6, which we're going to have to approximate on a calculator here. So I'm going to enter the exponent first, 0.0133, multiply that times 6, and okay, that goes into the exponent, well, we make it negative, then it goes into the exponent of the e, and then I'm going to multiply that times 4 to get 3, let's see if we round to the nearest tenth of a milligram, it would be about 3.7 milligrams. Okay, the next question is how long will it take for 4 milligrams to decay to 2 milligrams? That's basically asking what is the half-life. So for part B, I'll try to squeeze the work in here. We want to solve for t. How long will it take? That means we want the value of t at which the amount is equal to 2. Even though we start with 4. So I'm going to plug in 2 for A of t, or A of t right there. We're asking when does 2 equal to 4 times e to the negative 0.0133 t. So if we divide both sides by 4 to get that constant out of the way, then we have 2 over 4, or 1/2, equals e to the negative 0.0133 t. And we need to solve for t. So to solve, we need to take the natural logarithm of both sides of that equation. So we get the natural log of 1/2 is equal to the natural log of e to the negative 0.01133 t. And then we can bring that exponent down up front, or you can use the fact that the natural log of e to a power is simply that power. So we have on the right side of this equation simply negative 0.0133 t. So to solve for t, we can then divide both sides by that decimal number to get natural log of 1/2 divided by negative 0.0133. And we'll need to approximate that with the calculator here. So I'm going to take 0.5, take the natural log, and then divide that by 0.01, oops, I have to redo that, 0.5, take the natural log, divided by 0.0133, and it's negative, we get positive. We are rounding to 2 decimal places, so 52.12. And now for the last problem in part C. At what rate is the amount of Valium in the person's bloodstream decaying 6 hours later? That is the derivative at 6. So first we need to find the derivative at t. So I'm going to differentiate this function right here to find the derivative at t, and then we'll plug in 6. So the 4 just hangs out front, so it's 4 times the derivative of e to the negative 0.0133 t. Well, the derivative of e to a function is e to itself, so e to the negative 0.0133 t times the derivative of that exponent is negative 0.0133. That's just the coefficient of that t right there. Okay, so then we can, you could multiply the 4 times the constant, sure, and we can plug in 6 as well. I think I'll go ahead and multiply 4 times the constant first. So my calculator here, I'm going to do 0.0133 and multiply that times 4 to get 0.0532. So we have negative 0.0532 times e to the negative 0.0133t. And now we can plug in 6 to that. Right there. And see what we get. Okay, so we have, first we're going to multiply 6 times that exponent. We're going to do 6 times 0.0133. We'll make that number negative there. That is the exponent to e, so now I'm going to hit the e to the x button and multiply times 0.0532, which is also negative. So we get negative 0.04 119, and we're round the rate to 3 decimal places, so negative 0.049 it looks like. And that's it on this problem.